guys, I'm Maximus Baker and you just heard me playing through this modded JCM2000 head. This DSL head has been upgraded with the new bakeramp's replacement mainboard. Later in the video, I interviewed Rick Baker, who designed the replacement board, and he goes into the technical aspects of it, so you can skip towards the end of the video if that's something you want to see now. First, I want to give my opinions on this amp. A lot of people love this amp, but there's some common complaints about the high end is too fizzy and harsh and the low end is a little out of control. However, you can purchase a bakeramp's board in a modded version. The modded board takes care of the harsh high end and gives it a better low end response. After the mods, I think the amp is right where it's meant to be. You'll hear later in the video what a stock DSL sounds like compared to the modded version. One thing I noticed about the modded DSL is the gain structure is very similar to a Soldano SLO. When we were going through the circuit of the DSL, we noticed the schematic was nearly identical to a Soldano with some small value differences. So in the mods, the values were changed to more of a traditional Marshall or Soldano, meanwhile taking care of the high-end problem and low-end problem. And it sounds nearly identical to my SLO module from Synergy back here, and you'll hear that later in the video too. So now I'm gonna play a little bit through the modded DSL head, and there's some reverb on the track, but everything is straight into the amp, no effects or boosts or anything. Okay, go ahead and introduce yourself and talk about your background in guitar amps and electronics.
Sure, I'm Rick Baker. I first started doing guitar amps in the early 90s. I worked for a musician repair place in San Diego and done, thousands of repairs and music equipment stuff. Some for some, high profile rock star type people also. And then from there I went and I worked for Carvin for about a year. And then I went on to another company in San Diego that does real high-end mixer consoles and equipment for radio stations, audio stuff there. So that was my background to audio. And then after that, I got more into, manufacturing in engineering companies and stuff. It kind of left the audio end of it in electronics. So.
Okay, and you created a new main replacement board for the Marshall JCM2000 DSL heads.
Yes, and the TSL. I was looking for some mods for an amp on YouTube and stuff, and just searching around, and I started seeing all these things about the issues with this amp. And then I saw that Marshall doesn't provide a replacement board for it anymore. And that's when I started, looking into it, because I do, that's what I do professionally now, is I'm a PC board designer. And I knew exactly what the problem was just by, all the complaints and stuff. So after, investigating it a little further, I knew I could provide a replacement board for all these amps.
So yes, this is a pretty popular amp and a lot of people own them and a lot of rock stars used them, but they have a pretty common failure issue, right? So can you go over what kind of fails the main board has?
So after investigating it a little further, I can see exactly what was going on. I mean, other than just bad layout technique, I knew that because whoever laid out that board didn't know what they were doing. They didn't know probably how to order the board to withstand the high voltage on the board. So not all FR4 material is the same. It comes in a whole bunch of different types, different manufacturers, and it's all designed specifically for different needs. And in order to have a board that would withstand the, high voltage B plus voltage at, 450, 500 volts DC, you have to select the proper materials that will withstand that. I'm sure they just used the cheapest FR4 they could find to keep the price down. And unfortunately, they paid the price. They cheaped out and all their boards are failing because they can't withstand that high voltage. And what does it do? You have high voltage on the output tubes pins, and right next to it is the minus voltage for the bias. So you have, let's say, 450 volts B plus on one pin, and now you have minus 35, 40 volts on another pin. So it's the difference is, close to 500, maybe a little over, depending on what your B plus is. And that's where the breakdown occurs. You start getting FR4 material breaking down and becoming conductive. You lose control of your bias, and then the tubes run away from you, and it's downhill after that. And it's nothing that's going to go away on its own. It's just going to get worse until the whole thing goes up in smoke.
So how is your new board combating these issues?
Well, for starters, I used a better material. I picked a material that was rated for a higher voltage, and I increased the spacing of the parts and the traces even a little bit more to give me a little more coverage for that higher voltage. I also made sure that the solder mask, which is the color you see on the board, usually it's green, mine's purple, but I made sure that was a good thick layer, which also helps in combating that breakdown of the board. That's part of it. Another part that I did is on those original Marshall boards, they had an external bias board that connected through, I think it's like a 7-pin connector. So you have a 7-pin connector cable connecting this little board to the main board. So that's 7, and then times 2 connectors. That's 14 connections that you have. And if any one of those goes intermittent or fails, you lose control of your bias, and the way you lose, control of your tubes and more smoke. So I eliminated that. I put the bias circuit on the main board where it should have been, and put it in such a way where you can eliminate that external bias board without any issues. So.
And where can you find one of these boards? Let's say someone wants to order one.
Right now, I'm only selling them on Reverb. Go to Reverb and type in Bakeramps JCM2000. There's, I think, 3 different versions on there right now. There's the TSL, there's the DSL100, and the DSL50. All you do is just find the one that you're interested in and hit order.
Do your boards affect the original tone at all?
No. Originally, they're built to the same original stock Marshall specs as far as values and all that. So a lot of people love these amps, and I didn't want to change it. I want them to be able to get their amp working back the way they want it and keep on going. But I do know in this amp world, everybody likes to tweak and change things and modify and make it their own or make it closer to something else that it's more pleasing to their ears. So I did provide some accommodations for some mods on these boards also.
So there's a modded version you can get.
Yeah, I don't currently have it on Reverb, but you can still get it. You could just order the whatever board, the DSL100, for example, and just send me a text, hey, I want the modded version, and I'll go ahead and build you up or just modify one of the existing ones I have in stock. So.
And what does the modded version do? What does that fix or change?
Well, the first thing it does is it takes out some of the bright fizziness that a lot of people complain about in the amp, and some of the flubbiness in the bass. So basically all it's doing is pulling some of the bass frequencies out of the front end and adding them back in towards the later stages of the amp. It's also adding a depth circuit, which is different than the depth switch that is on the amp stock. The amp stock comes with that depth switch, and it's this goofy little circuit that it spits out a little signal, trying to make it so people can understand. It spits out a little signal that simulates a depth circuit and spits it back into the phase inverter. So it's kind of simulating, and it only gives you, on or not on. And even with it on, it's very subtle. I mean, it's better with it on. It's terrible with it out. So
I hear a lot of people complain that with it out, it's like horrible, and with it in, it's too much sometimes. And you're having to use like pedals to compensate and tone shape it. But with your new depth circuit, it fixes all that hassle.
Yeah, it kind of makes it a fixed value, once it's in there, but it fattens it up. And I believe there's some audio clips that you're going to play, and you can actually hear the difference, what that does.
So who has the type of skill to install this board? Is this a job for somebody that needs a lot of experience or moderate?
That's what's really nice about this. The way the board's designed, there's no soldering involved, which is nice because not everybody knows how to solder. And so all you're gonna do is pull the tubes out, open the Marshall up. You're gonna undo the screws at the bottom. You're gonna slide the chassis out, and then there's some screws that on the board itself. I think there's 6 screws that you undo. There is a bunch of connectors. You just unplug them, and and then the board comes right out. And then you're gonna have to unscrew that little bias board off the back of that metal tray that the board sits in. You remove that, remove the board. It comes out. You put the new board in. You screw it back in, and start reconnecting all the connectors. Also, I do provide access to a connector chart so you don't wind up making mistakes and connecting the connectors all wrong. Because it would be very easy to do. They're all the same type of connector, and they can all go anywhere. So unless you labeled them when you pulled them off, you're going to have a hard time putting them back on. But with the chart, it's easy. You just follow the chart, and it tells you where they go. So this is a board out of a DSL, and we're just going to go over some of the issues with the board and show you some examples of what bad layout looks like. So for starters, here's this bias board that's connected with this little cable. So, every one of these crimp connectors on here can become a failure point for your bias control. So if you can eliminate all that, all the better. Also, in board layout, there's, some good practice things. There's a lot of do's and don'ts. And I'm going to show you a big don't. One thing you don't want to do is run traces underneath components unless you absolutely have to. One example of this is you can see this trace running underneath here and through all this sensitive preamp stuff. So that's not good, especially that's a high voltage line that feeds power to all these preamp tubes. So that's bad. And also you can see it down here. I mean, they run it under bare jumpers. And the only thing separating this jumper from that trace is the very thin layer of solder mask, the green stuff they put over this. So if that fails, it's a short and bad things can happen. Not to mention the sensitivity with noise and things that can go wrong. One of the things I didn't like about the way they did it is they used these power resistors that are stood way off the board. Anytime you have something that's way up off the board, it's more susceptible to vibration and impact. The amps dropped or banged. There's more leverage, and you develop bad solder joints and things. On my boards, I actually take these resistors and I put a thin layer of silicone. It's like a silicone tape, and I put it underneath this, and then I seat them down flush to that. So they're down solid, but yet they're still have the spacing off the board in case one goes up in smoke, or you're not going to be getting heat transferred to the board either. So it's a lot more robust. Also, you can see, it's easy to see on these connectors for the preamp tubes, you can see none of these have solder on the top side. It's only on the bottom. And, a lot of people will probably see, bed over, time, you'll start seeing broken solder joints and they have to go in and resolder them. But if they would just do it, a more quality job and actually spend the time and solder from the top side also, all the resistors, everything should be soldered from both sides. My boards are all class 3, which means the level of quality is a lot more. And one of those inspection points is they're supposed to be soldered from both sides. So you'll see that on my boards and you won't see that on anybody else's. One of the other issues I noticed when working on these amps, this thing mounts down into that tray, and if you look down at board level, you can see that this board runs flat, and then there's a little jog here, and because it changes depth or level. It goes here and it drops, and what it does is it puts some stress and it flexes this board, and that's only because these sockets mount flush against that tray. This is as low as this is the standoff. Board's not going to sit any lower than this metal shelf of these tube sockets. So, and then they put in these little standoffs here, but they're actually a little shorter than the height of these, and that's why it changes levels. On my boards, I actually spend the time and custom machine these standoffs so they're the same height as the top of these. So when you put the board in, it sits flush, you screw it down, and that's it. There's no flexing of the board to try to get it to fit or anything.